Hello everyone, myself Dr. Gargi and I shall be talking on 3D reconstructive forensics, where 3D technology is being utilized for the reconstruction and visualization of the fragmented remains. First of all, greetings from National Forensic Sciences University, which is situated in Gandhinagar, Gujarat, India. At the National Forensic Sciences University, we have Laboratory of Forensic Odontology that deals in the dental identification and has advanced setup which includes 3D scanning, 3D modeling and 3D printing. Identification through skeletal analysis and dental identification is a frequently applied method of forensic investigation, especially in cases where the human remains are decomposed, charred, or skeletonized. The remains obtained in these cases at times are fragmented, occasionally with missing elements, which may in turn hamper the process of identification. In these cases, reconstruction of missing and fragmented remains is necessary. Traditional adhesives like fluid, glue, and tape are used to rejoin and reconstruct these fragmented and burnt remains. The traditional method for replacement of missing parts involves reproducing the external integrity of the bony segment by means of dental wax or hot paste made of organic and inorganic components, where to reconstruct missing tooth, basic dental materials have been used. Using traditional methods where the remains are burned or fragile, the handling of the remains becomes difficult, and this improper handling may further lead to the destruction of evidence. To overcome this limitation, we propose the use of 3D modalities, as 3D data acquisition allows to record the evidence from all the aspects by merely touching the remains. Reconstructive forensics. Reconstructive forensics refers to the reconstruction and remodeling of fragmented and missing elements of the evidence, thereby reconstructing the profile of the evidence in question. Integrating reconstructive forensics with digital manufacturing technologies would be beneficial, particularly when the handling of fragmented and burnt dental remains could damage the specimens. This presentation highlights the application of 3D scanning, 3D modeling, and 3D printing to reconstruct the fragmented and missing elements of the unidentified anthropological and dental remains. We have divided this complete presentation into two parts where in one part we would be discussing about the techniques of the 3D reconstruction of missing elements, and the next section we will be discussing about the 3D reconstruction of the fragmented elements or fragmented remains. So talking about 3D reconstruction of missing elements, the first topic we would be discussing is forensic tooth reconstruction. Forensic odontology deals with the who part of the investigation, that is, the establishing the identity of an individual. It demands the highest possible degree of accuracy to give a positive identification. In unusual instances, teeth may be dislodged due to postmortem loss or due to the mishandling of the evidence during the search and recovery process. Moreover, careless handling in collection, transportation, packaging, and dispatch for the examination of the human remains from the crime scenes or in exhumations may further contribute to this tooth loss. In such extreme situations, retrieval of the information may become difficult and challenging for a forensic odontologist as teeth are unavailable for examination. Your reconstruction of tooth morphology may aid in the identification process. The term forensic tooth reconstruction refers to the process that aims to reconstruct the morphology of the missing tooth from the intraalveolar morphology of the dental socket. The study is an attempt to develop a digital approach to reconstruct three-dimensional models through recording intraalveolar morphology of the empty dental sockets. So for this in vitro experimental study in phase 1, we obtained a mandible from the archives of the laboratory, after which we removed first, second and third left molars from the mandible. We assessed the internal morphology of the sockets for its integrity, after which we acquired a CBCT data of this mandible. This CBCT data was further segmented and 3D printed for the focus area or the area of interest. Phase 2 was the phase of reconstruction. In this phase, we took the impression of this 3D printed model using flowable dental materials, after which we scanned this impression and using the software, we reconstructed the tooth digitally, after which we 3D printed this complete model in SLA material. The accuracy of the reconstruction, we used the original teeth as the reference model and we performed morphometric analysis. It was observed that the anatomy of the reconstructed root resembled the anatomy of the natural tooth root. Metric analysis of this root showed the error of 0.26 mm to 1.21 mm. We did a qualitative congruency analysis test where we superimposed the 3D printed scanned model on the original tooth model, which showed the overall morphological error of 0.44 plus or minus zero point 0.5 mm. And we also performed radiographic analysis where we put this 3D reconstructed teeth, that is 3D printed teeth in the original dental socket. So from the image, it can be inferred that there is an appropriate adaptability which can be seen by the arrows. Next, we reconstructed the missing bony features. For this, we obtained a cranium with missing zygomatic process bilaterally from the archives of the laboratory. To reconstruct this zygomatic process, we obtain another cranium with intact zygomatic process of similar age and origin. Digital scans of both the crania were then sent to the software. The test cranium, that is the one on which the reconstruction was to be performed, was assigned as floating object and the reference cranium was assigned as the fixed object. After doing this, the superimposition was done using manual alignment and the global alignment, and fine tuning was done. As seen in figure B, the zygomatic process from the reference cranium was extracted and was then placed in the floating object, that is the test cranium. The bridge between the zygomatic process and the cranium was then filled and a complete object was created. This was then finally 3D printed and assessed for its morphological accuracy. In 2004, Gunsby et al. Documented that when one of the paired bones is missing, reflecting the intact side and mirroring it on the other half can aid in reconstruction. In 2009, Benzi et al. Used geometric reconstruction where digitally they reconstructed the missing cranial bones. This method provides for slightly less reliable results and has more dependence on the properties of the reference shape. In the present experimental approach, bilaterally missing zygomatic arch was reconstructed digitally. For reconstruction of the zygomatic process, the two crania were superimposed. With 34 iterations of maximum 100 iterations, average deviation was 0.98 mm, whereas the standard deviation was 0.79 mm, which ensured the maximum positional accuracy, which may further add on to this digital approach. However, the overall result would definitely depend on the properties of the reference shape that was taken. Moving on to the next section of the presentation, that is the reconstruction of the fragmented remains. For this, we obtained various dental and osteological remains. We also replicated few remains and fragmented them. We scanned each of the fragments individually and then finally sent it to the software. In the software, based on the fragment lines, we identified the homologous points on the fragments and aligned it. This slide is a short video demonstrating the scanning and the reconstruction process. These reconstructed models were then finally 3D printed and were analyzed for their accuracy. For the mandible, the linear metrics were performed and the osteometric analysis showed that the discrepancy was between 0.02 mm to 1.14 mm, whereas the odontometric analysis performed for the reconstructed teeth showed that the discrepancy was 0.01 mm to 0.58 mm. We also performed the qualitative congruency analysis. For the mandible, the overall morphological error was 1.55 plus or minus 2 mm, whereas for the teeth, the morphological error was 0.0526 plus or minus 0.05 mm. Integrating 3D technology with the reconstructive forensics has various applications. One of the major applications is that the fragmented models or the fragments or the completely reconstructed models can be stored in the digital format or can be 3D printed and stored for the longer time. They can be revisited again whenever necessary and in the absence of the original specimens. Metric and non-metric analysis can be performed on this since the accuracy of these models was within the acceptable range. This can be used for the comparative identification, be it dental identification or osteological identification. Forensic tooth reconstruction in the absence of the original tooth, that is the post in cases of post-mortem missing teeth, can help in understanding the root developmental stages. This is an humanitarian approach since we are not damaging the original evidence. This reconstructed specimens, that is, if we can reconstruct the fragmented skull or a mandible, they can be used for the forensic facial reconstruction. One of the major advantage is that the original specimen can be sent for the DNA extraction and after scanning, and all the analysis can be performed on the scanned models. Hence, we can revisit this model again and again. To conclude, this present work is a compilation of pilot studies on different type of reconstruction, that is in case of missing elements and in case of fragmented remains using 3D modalities. A combination of 3D reconstruction of missing and fragmented pieces can be used in forensic context and is also an humanitarian approach. The overall reconstructed specimen showed minimum error rate of 0.01 mm, whereas maximum was of 1.50 mm, implying that the reconstruction done using these techniques and software can further be evaluated and validated on large number of samples and can be used effectively in forensic practice. Therefore, the continuation of this kind of work will help better in investigation and human identification. Thank you.